For as long as we've been looking up at the stars, we've been driven by this one massive question about our own place in the universe. It's the one that really gets the imagination going. Yeah, that one. Is there another planet somewhere out there that's anything like our own? Well, today we're going to follow the trail of one of the absolute best leads we've ever had in that search. And trust me, it plays out just like a cosmic detective story. So meet our main suspect. It's an exoplanet about 40 light-years away called TRAPPIST-1d. Now, for years, this planet has been right at the top of every astronomer's most wanted list. I mean, it seemed to check all the right boxes for being an Earth-like cousin. But what does the evidence actually say? To really get this story, first we've got to open up the case file. Let's see exactly why this planet got everyone so excited in the first place. What made it such a prime suspect? And honestly, the initial file, it looked almost too good to be true. TRAPPIST-1d is a rocky planet just like Earth. It's about the same size as us, and, the big one, it orbits right inside its star's habitable zone. You know, that perfect Goldilocks region where temperatures could be just right for liquid water. On paper, this was a slam dunk. But here's the very first clue that things in the TRAPPIST-1 system are, well, a little weird. The planet's entire year, one full trip around its star, takes just 4 Earth days. That is incredibly fast, and it tells us something really important about its neighborhood. The reason for that super short year is the star itself. TRAPPIST-1 is what we call a cool, dim red dwarf. It's way smaller and less powerful than our sun, and that means its habitable zone is huddled up incredibly close. TRAPPIST-1d orbits at just 2% of the distance between the Earth and the sun. So we're talking about a totally different kind of solar system, which made investigating it both a huge challenge and an even bigger opportunity. Okay, so to crack a case this far away, you need the best detective in the business. And that is, without a doubt, the James Webb Space Telescope. It came to this investigation armed with a very specific and very powerful tool for interrogating planets. This amazing technique is called transmission spectroscopy, and it's just ingenious. As the planet passes in front of its star from our point of view, Webb carefully analyzes the starlight that actually filters through the planet's atmosphere. See, different molecules in that atmosphere absorb specific colors of light, and that leaves behind a unique chemical fingerprint that Webb can read. It's basically like dusting for prints without ever stepping foot on the scene. So what was on Webb's search warrant? Well, it was pretty clear. Its super powerful NIR-spec instrument was programmed to hunt for the telltale signs of a thick Earth-like atmosphere. It was looking for the big 3, the stuff we know and love: water, methane, and carbon dioxide. If these were there in big amounts, it would have been an absolutely monumental discovery. So the target was locked, the tools were ready, the observation began. The data streamed back to Earth. And I imagine the entire scientific community was holding its breath, just waiting for the verdict on this potential Earth twin. And then we got it. The lead author of the study, Carolyn Pialet-Gorab, put it pretty bluntly. The main theory, that this planet was an Earth-like world with an Earth-like atmosphere, was officially off the table. Webb's incredibly sensitive instrument stared and stared at TRAPPIST-1d and found, well, basically nothing. No big fingerprint of water, no methane, no carbon dioxide. The data showed 0 signs of a puffy, welcoming atmosphere like our own. The case of the Earth twin was officially closed. But the investigation? Oh, that was far from over. Because here's the cool thing about science. Sometimes a no is way more interesting than a yes. This result didn't just end the story. It sent it down a brand new, totally fascinating path. It's opened up 3 new lines of inquiry for what TRAPPIST-1d could really be like. So, what are we left with? Okay, possibility 1. It could be like Mars, with an atmosphere so incredibly thin that Webb's instruments just can't pick it up yet. Possibility 2, it could be like Venus, totally wrapped up in thick, high-altitude clouds that are basically a celestial smokescreen, blocking our view of what's underneath. Or possibility 3, the simplest, maybe most likely explanation, it's just a barren rock with no atmosphere at all. And there's a really good reason to suspect that last option might be the one. The problem isn't the planet itself. It's the parent star. Turns out, living this close to a red dwarf is a pretty dangerous business. See, the TRAPPIST-1 star is volatile. It's known to frequently erupt with these high-energy flares, just blasting its inner planets with waves of harsh radiation. An environment like that is incredibly hostile to a fragile atmosphere. Over billions of years, that atmosphere could have just been stripped away and blown out into space. Okay, so if this planet is probably a dud, why does this matter so much? Because this result is a vital clue in the much larger investigation. It helps us understand the rules of the game for finding life in the rest of the galaxy. You see, red dwarfs are the most common type of star in our galaxy. So, the TRAPPIST-1 system is the perfect stress test. If any of its planets can hold onto an atmosphere in such a tough neighborhood, it dramatically boosts the odds of finding habitable worlds elsewhere. As the saying goes, if a planet can make it here, it can make it anywhere. And the investigation is far from over. The detectives are now turning their attention to new leads, the outer planets in the system. These worlds are a little further away from the star's violent temper tantrums, giving them a potentially better shot at holding onto their atmospheres, and maybe, just maybe, some liquid water. So the real takeaway here isn't disappointment, it's progress. Ruling out a suspect isn't a failure in a detective story, it's a critical clue. It helps us refine our search, and it tells us exactly where we need to look next in our huge quest to answer that universal question, are we alone? Every single observation, even a null result like this one, gets us one tiny step closer to an answer. We've crossed one big suspect off the list, but the cosmos is filled with countless others. The ultimate question is still out there, and the search for another Earth absolutely continues.